Alright, we're going to do second law. We're going to start with question number 1. A constant unbalanced force is applied to an object for a period of time. Which graph best represents the acceleration of the object as a function of time elapsed? So if acceleration is constant, that means it does not change. So it's going to have a constant. It does have a magnitude greater than 0, but it's not going to change. It's going to stay constant. And this would be an example of like gravity. It's always going to be at 9.8 meters per second. It's not going to change. Okay, question number 2. The diagram below shows a horizontal 12 Newton force being applied to two blocks, A and B, initially at rest on a horizontal frictionless surface. Block A has a mass of 1 kilogram and block B has a mass of 2 kilograms. The magnitude of the acceleration of block B is going to be, and your answer you should have chosen is the 4 meters per second squared. And the reason for that is that you need to account that each of these are together, and so because they're combined and they're in motion, you can't separate the two out. So that means that second law is force equals mass times acceleration. You have to combine the two masses as 3 kilogram object, which equals the total force being applied, which is 12 newtons, times the acceleration. So your answer is 12 divided by 3, which means your acceleration is going to be 4 meters per second squared. Question number 4. The weight of a typical high school student is, and your answer should be 600 newtons. So when we're talking about how much most people are, so for instance, you're going to have your kilograms to Newton ratio. You're going to have somebody who, about 60 kilograms is pretty much what an average person, student would weigh, and then that means in newtons it can be rounded out to 600 newtons. And we did this entire activity when we were talking about energy conservations and converting the different weights and from newtons. So this is just your mass that you would have, which is in kilograms, and you multiply that by gravity, and that gives you your force. Okay, the next one is question number 10. A man standing on a scale in an elevator notices that the scale reads 30 newtons greater than his normal weight. Which type of movement of the elevator could cause the greater than normal reading? Your answer should be choice number 3. Because if it's moving upward, that means this force is being applied in the upward direction, which means he's going to be pushed down on the scale. It's also going to be constant because he doesn't have abnormal readings. He can read that it's 30 newtons greater. Okay, question number 11. Two forces, F1 and F2, are applied to blocks on a frictionless horizontal surface as shown. If the magnitude of the block's acceleration is 2 meters per second squared, what is the mass of the block? So we're looking at the newtons. If I have 12 newtons and 2 newtons, that means I need to figure out what the difference between these forces are, which means I have a total force, net force, of 10 newtons. And then we're going to just apply that to the F equals ma second law equation. So 10 newtons is equal to my mass, which is unknown, times my acceleration due to gravity, which is given to me as 2 meters per second squared. So 10 divided by 2 will give you 5 kilogram block. And so that should have been choice number 2. Okay. Alright, the next one we're going to do is question number 16. So, which diagram represents the box in equilibrium? So, if you're looking at the box in equilibrium, we're looking at in each direction. So, that means we're going to have 5 and 5 and 2 and 2. They're based on the opposites of each of those is going to be in equilibrium, which means you're going to have it zeroed out. Alright, and next is question number 17. The diagram below shows a 5 kilogram block at rest on a horizontal frictionless surface. Which diagram best represents the exerted force on the block? So you need to know what the block is doing. The block does have an acceleration because it's due to gravity. So everything, no matter what, is always being pulled down. So the acceleration is 9.8 meters per second squared. And the block has a mass, which is 5. So we do know that if I multiply the mass times the acceleration, I can get the force of the block, which is going to be 49.1 newtons. So if the force of the block is 49.1 newtons, that means that the only reason that the block isn't moving is because that the table is pushing up on the box at the same, which is 49.1 newtons. So that means that your answer choice should have been answer choice number 1. Okay. We're going to do next question number 28. Question 28 says that we have a scale diagram, so you will need a ruler for this. Using a ruler in a scale diagram, determine the magnitude of F2 in newtons. So if I just measure the magnitude, I'm going to measure the magnitude of this first and develop a scale. You should have about 1.7 centimeters, which is equal to 12 newtons. So if we, and then I measure this side over here, and this is about 0.9 centimeters long. So that means we have 0.9 centimeters. You want to make sure that you divide that by the 1.7 that you had remaining. So let me just kind of write this out for some of you that had trouble with conversions. I've measured the 12 newton side, which is equal to 7.1. Oh, I'm sorry, whoops, 1.7 centimeters long. So this is my scale. For every 1.7 centimeters, I have 12 newtons. I measured this side, which is F2, and F2 turned out to be the length of 0.9 centimeters. So if I know that this is 0.9 centimeters, I know I can convert. So 0.9 centimeters, for every 12 newtons, I'm equal to 1.7 centimeters. So 1.7 to cross out my centimeters, and that gives me my 12 newtons, because newtons is what I want to know what the magnitude is on the other side. So sorry. So 0.9 times 12 divided by 1.7, and you're going to get a magnitude of 6.35 newtons. So this is F2. Okay. Question number 29. Determine the magnitude of the net force acting on the block. So 12 minus 6.35. We're looking for the net force. And that's going to equal 5.65 newtons to the right. Okay, and number 30. Calculate the magnitude of the acceleration of the block. So we're going to use F equals ma. We know the force is 5. The net force is 5.65 equals my mass, which is 4, times my acceleration. So 5.65 divided by 4 gives me an acceleration of 1.41 meters per second squared. Alright, the next question we're going to do is question number 42. And 42 says, a force of 25 newtons east and a force of 25 newtons west act continuously on a 5 kilogram cart. What is the acceleration of the cart? If the net force is equal to each other, velocity can still be constant, but there's no acceleration. So that means that your answer should be 0 meters per second squared, because they cancel each other out. For 43, a high school physics student is sitting in the seat reading this question. The magnitude of the force with which the seat is pushing up on the student is to support him is going to be closest to 600 newtons. So we already talked about before that we know that the mass of an average student is 600 newtons, which means that the mass pushing up against the student to hold him in the chair will also be 600 newtons. Okay. Again, if you have any questions on second law that you wanted to see that I didn't do here, just make sure that you ask.